We're live.
Okay, is YouTube live?
Yes, it is.
Okay. Well, somebody needs to be muted. Ken Burton, I think you need to mute. Thank you. Okay, welcome everyone. I am sitting in for Diane Hall, our president, who cannot be here this evening. As the first vice president, it's my job to fill in for her if she can't make it. So welcome, and we're going to jump right into things. I'm going to try to share. We're going to do in the news first. Let me see if I can get it up. I don't see it. Can you guys?
A gray screen again.
Let's try this again. I'm working on it. Can you see it now?
Yes, we do.
Okay.
I see it.
Okay. Tonight I'm going to cover in the news. First news item concerns Saturn. I think we all know, Saturn is that big thing with rings. It's also rather unique in that it has by far the lowest density of any planet in the solar system. Its density is 70% that of water. Hypothetically, if you could put it in your bathtub, it would float. Hypothetically.
Or would it leave a ring?
Yeah. Yes. Hopefully it would not leave a ring behind. Good one. So there's a new study out by two astronomers at Caltech who realized that the inner rings of Saturn could serve as a seismometer. If Saturn oscillates a little bit, its gravity would change, affecting especially the inner rings, making them oscillate in response. So they become a sensitive seismometer. This is based on, they did their study based on old Cassini data, the Cassini spacecraft data that orbited Saturn for several years, I think until about 2017. And what they see is by looking at oscillations in the rings, they infer that Saturn quivers like heavy jello or a very thick jello, its gaseous surface heaving up and down by a meter or so every couple of hours. So the picture that they are able to infer of the interior of Saturn is that there's no abrupt transition from one layer to another. It's a very gradual thing that more and more rock gets mixed into hydrogen and helium as you go deeper and deeper into Saturn. And they say they think Jupiter may be similar in that regard, just a gradual transition. Something I was surprised at is, probably should not have been, but I was. There's a new European radio telescope array that just went live. Their older array, codenamed LowFire, that array of antennas imaged several galaxies seen in the upper picture. the new, much larger array that covers a good part of Europe. The old one was all in the Netherlands. The new one is 70,000 antennas covering much of Europe, has 20 times higher resolution. And so the same galaxies are imaged with a lot of detail in the lower picture. So I'm sure we'll be getting some really good science out of that array. What surprises me is I'm sure Europe is awash with all kinds of radio frequencies. So I'm a little surprised that they could not be interfered with this array and get this clean of data. Another new development in astronomy is that there's a new way to measure the mass of a black hole, which can be challenging to measure. The best way to measure it is if you can see something orbiting the black hole, like a star. That's why we know the mass of the black hole at the center of our galaxy so well. We can see several stars orbiting it, measure their paths, and figure out the mass. Black holes are often surrounded by what's called an accretion disk of material, stuff like gas and dust and other debris. Some of that material can fall toward the black hole, emitting a burst of energy as it falls. This causes the light from the accretion disk to brighten or flicker. Turns out, the more massive the black hole is, the longer the flicker time. This flicker time can therefore be used to measure the mass of a black hole. This has been checked out with masses from 10,000 to 10 billion solar masses. So over a range of masses changing by a factor of 1 million, this technique works really well. They're not sure what the mechanism is yet, but that'll be explored heavily, you can bet. And then there's an old friend, the Ring Nebula, Messier Object 57. There's a standard picture of it shown in the upper. Somebody needs to mute themselves, please. I can hear somebody's got an open mic. The upper picture is a standard high resolution picture in visible light of the Ring Nebula. Many of us have seen a not quite so clear image of it ourselves with our telescopes. The lower picture is a newly released one, which includes infrared data, showing that it's way bigger than we can see with visible light. And that's in the news for today. And Mark is now going to show us in the sky.
Hey, good afternoon, good evening. Can you guys hear me okay?
Yes.
All right. So in the sky, I figured we'd start out really close to home and just look at the weather here for the next few days. And the arrow right here is us. You can see the jet stream is pretty well broken up, pushed to the north of us. We still got some high velocity winds here meandering through the area, so it's not ideal, but it's pretty darn good. The lower picture is showing the forecast for Sunday, so we're going to stay out of the main jet stream area. Should have pretty good seeing here in the next few days. And just keeping an eye on forest fire smoke. This is particulate matter, 2.5 micron current forecast. So right now, if you look outside, it's a little on the milky side. You can see we've got some smoke rolling in through here. And then Sunday, we get a little reprieve, but looks like we're going to be battling that smoke for a while. Our forecast the next few days look pretty darn good. And looking at clear sky chart, the seeing forecast isn't ideal, but we've got a number of hours in here that are forecasted to be 5 out of 5. Not always perfect, but anytime we get lots of humid, stale air, seeing usually is pretty decent here. And the seeing is important for some events that are occurring on Jupiter this evening. Tonight around 9:50, we've got Io. It'll be sitting right on the limb of Jupiter. And you might want to start a little early. These times will be approximate. This is just taken out of planetarium software. But you can see Io, because we're so close to opposition, Io's shadow is cast virtually straight behind it. So tonight offers a unique opportunity to catch Io, including a portion of its own shadow transit. The shadow is slightly following. So you should see Io hit the dusky kind of limb of Jupiter, make it stand out really good. And then you should see the shadow start coming in, taking a bite out of the limb of Jupiter. And you get a really nice contrast effect because the limb of Jupiter is a lot darker than the central meridian. And with the shadow, it allows you to track Io much easier as it passes across the face of Jupiter. It looks like it's going to fall in the equatorial band, which is a lot lighter, makes it a little more challenging to see. But with the shadow, I think it's going to be pretty easy to pick out the orb of Io probably across the whole face, which is pretty exciting. And then lastly, you don't need a real big scope to observe this, especially the shadow transit. Io itself is 1.3 arc seconds, but if you remember that extended objects aren't necessarily constrained by Dawes limit, and the Cassini division is only 0.5 arc seconds. So you can easily resolve one of these shadow transits with a 60 millimeter or 70 millimeter refractor. You don't need fancy equipment to do it. And you've got very high contrast in these shadow transits, so you can push the magnification. So by mid-transit, Jupiter's at an altitude of 23.5 degrees off the horizon, which is pretty decent considering how low it's been the last few years. And you'll notice that Io and its shadow are closing the gap to the Great Red Spot, which will be rotating nearly out of view around 11 p.m. So you don't have to stay up too late to see this. And then by midnight, we've got Jupiter at 30 degrees. I think that's as high as it's been here in the last number of years. And it'd be a nice sight to see Io again on that dusky limb with the shadow nearby. Friday night, kind of interesting also, Europa will emerge around 10 o'clock from the shadow, from Jupiter's shadow, which is nearly at the limb because again, we're so close to opposition. So that should be an interesting phenomenon to observe also, to see a sliver of Europa and then Europa come into full view just off the limb. Obviously best to watch with high magnification and in a bigger scope, but I think you could probably enjoy this in a small refractor as well. And then Saturday night, just a reference, Great Red Spot is going to be at the central meridian around 11 p.m. So you don't, again, have to stay up too late. And Jupiter's 49 seconds in diameter right now. So I call it free magnification when we're at opposition and the planets are nice and close. You can see a lot more without having to use a whole lot of power. So that helps out with our atmospheric seeing issues here in Michigan. And you should be able to see the Great Red Spot. I've seen it in a 60 millimeter, 80 millimeter should be no problem at 11 p.m. Saturday night. And we've got good seeing forecast. So all month, don't forget about Saturn. They're rising earlier every day. The days are getting shorter. So we're coming into planet season right now. And then I also want to mention a double star that's starting to fall almost out of season, but Russell Gethy is one of my favorites. It's a really nice color contrasting pair. It falls in currently the southernmost star in Hercules. It's a pair with 3.4 magnitude It's a red giant, but it appears orange/red. And then its companion is 5.4 magnitude. I think it's a main sequence star, but it appears greenish because of the strong orange-red primary star. And these are actually the primary is a what do we call it? Somebody help me out. I'm forgetting what it's called. A variable star that fluctuates between 3.1 and 3.9 magnitude every 90 days. And lastly, the secondary is a spectroscopic binary. It's kind of interesting. And that's all I have for in the news. I kept it local and with one double. That is a nice thing to look at while we're going through full moon weekend.
Okay. Thank you, Mark.
You're welcome.
Again, I'm filling in for Diane Hall tonight. And so we're going to go through the officer reports. I have some announcements. Our next meeting normally is on the first Monday of the month, but that's Labor Day in September. So our next meeting will be on the second Monday of September, September the 13th. And as usual, it'll be a virtual meeting. Then, what an announcement. At our last meeting, we announced that the board had decided to not go ahead with the annual picnic, which was scheduled for the last Saturday of this month because of concerns about COVID, because cases are ramping up with COVID. The board agonized, I can tell you, over this decision. And within the last few days, we have agonized some more over the possibility of having not a full picnic, but just a swap meet where people could buy and sell astronomy gear to each other. So here's where the board is at on this as of an hour ago. If some people wish to meet at the pavilion just north of our Stargate Observatory and have an informal, not a sponsored swap meet, not this Saturday, but August 28th, Saturday, from 4 to 6 p.m. We can't stop you. For those who come, we would encourage the use of masks and social distancing. We would discourage bringing minors, pets, or food. Some people might not want to buy or sell something, but just want to hang out with each other, since many of us have been, no personal contact for over a year now. So again, the time of this non-official event would be Saturday, August 28th, starting at 4 p.m. at the pavilion just north of Stargate Observatory. How's that for an announcement? Finally, we're only about 3 months out from having our annual election to elect officers for next year. It's not too early to think about whether you'd like to run for an office. If you're interested, please contact anyone on the board. I'd be happy to talk to you. So that was the quote unquote president's report. Now I will give my report as first vice president in charge of program. As I mentioned, our next meeting is September the 13th. Jim Shedlowski will give the main presentation on the Giant Magellan Telescope. Gary Ross will give the short presentation, Hubble and the Known Universe. We're going to hear from Hubble himself in that presentation. And Gary wishes to acknowledge his two co-conspirators on this presentation, Clayton Carey and Dale Teamy. So that'll all be on September the 13th, our next meeting. Then on September the 16th, Tony Licata will give a presentation entitled The Hamburg Meteor. With that, I'll call on Riyad Mahdi, Second Vice President for the observatory, for his report.
Thank you, Dale. Hello, everyone. I was able to visit the observatory just this last Saturday, August 14th. We had a gentleman who just recently joined the WAS, and he wanted to borrow one of the scopes, so I met him there. We both had our masks on, and we did not get in the same building at the same time, so I had him basically borrow the 8-inch Dobsonian reflector that we have. While I was there, of course, I visited, I monitored the observatory to make sure that everything was still good. All the equipment are there, and the building is fine. So we're in good shape still. Of course, as was just mentioned, we don't have a picnic. So on the 28th, we do have an open house. However, if Doug is going to be available, I'm not sure, then maybe we will have still our virtual open house, unless he's going to be at Stargate as well. So I'm not sure. That's something to be discussed still. So that's all I have right now. And of course, if we were to, once we decide to go back for in-person observing, we'll let everybody know. But right now, the observatory is still closed for such events. Thank you.
Okay, thank you, Riyad. I think Adrian Bradley, our treasurer, could not make it tonight. He had issues come up at work. So I would refer you to the latest issue of the WASP for a recently up-to-date treasurer's report. And I think it's probably reasonably close to where we're at today. Next, the secretary's report from Mark Kedzier.
Good evening, everyone. I have nothing to report as for WASP stuff, but I do have something to report through our Ferndale Library. Person by the name of Jordan contacted us regarding the library telescope program, and Jonathan made contact with them, passed along the information, and their library has purchased 3 Orion Star Blast, and I will be working with them and modifying the scope so they can get it ready for circulation for the Ferndale Public Library. So that's good news, and that's all I have to report.
Okay, that's great, Mark. Thank you. Okay, next is outreach by Bob Tremblay.
Well, oh my goodness. Where do I start? Well, shortly after the board meeting where the WASP board was agonizing over canceling their picnic, GLAC was agonizing over canceling astronomy at the beach. And well, they've done that. We're canceling the in-person event for obvious reasons, and we're going to be pointing visitors to our members who would like to live stream. We're not planning on doing a whole lot of presentations, if any, this year. We just want to keep it simple. We feel everybody is getting kind of like Zoom burnout, But we do want to get some people doing some live streaming. So if you're interested in that, I sent out an email to the membership about that. If you're interested, get with me and or Jeff Kopmanis, the GLAC secretary, and we will work on scheduling you to do broadcasting of telescope stuff during Astronomy at the Beach. I am going to be well, Dale Parton came up with that idea, and I'm working with him, but I'm probably going to be taking it over. We're going to be doing a presentation in early 2022. What got you interested in astronomy? So I sent out an email. I would like to record some people, just interview you, talk about that. If you got pictures, that would be great. So I've already got a couple responses on that, and I will get with you about recording and interviewing and stuff. So if you're interested, let me know, and I will talk with you about that. Other than that, I still have to get out an email out to libraries. I've got a couple. I've got like Dale and Ken Burton's presentation. So if you have presentations that you would like to give remotely to libraries, just give me a list of them, and I will send that out. I think that is pretty much it for outreach.
Okay, thank you, Bob. Last but certainly not least, our award-winning publications chairman, Dale Teamy.
Thank you, Dale.
Dale, tell us what happened today.
Well, today I officially got recognized with the Astronomical League for the award. So that's somewhere in their stream, which I'm sure
This was an award for what?
Oh, the newsletter award.
Thank you for clarifying that.
Okay. But anyways, yeah, I was recognized and had to say something by way of thanks, and managed to survive that. And meanwhile, working on the next issue of the WASP is coming along very nicely. What month is this now? The August issue is up. Working on September. It's coming along very well, thank you.
Okay.
Cards and letters coming.
Thank you. Okay, those were the officer reports. Next, we have some special interest reports, depending on who's here to give such reports. Do we have someone to give a report on solar observing?
Yeah, hold on a second. I got a couple
Usually
screens up
got
here.
Bob really usually got something really good.
Yep, I do. Hold on, I got
Yep.
solar dynamics. So let me. Where's the WebEx now? I've got too many windows open here. Share. I want to share that screen. Okay, we are looking at images. These are animations from the solar dynamics observer. You guys can see the sun, right?
Yes.
Okay, I got two images
Yes.
here. On the left is pretty much what you'd see with hydrogen alpha. So you're seeing the chromosphere and prominences and stuff like that. Over on the right is ultraviolet, and you're seeing the corona. And take a look at the center there. That thing is just boiling. And so there's a lot of interesting stuff going on. And up in the upper left of the yellow image, you're seeing plasma indirection. That's essentially they look like tornadoes in the corona. So when this thing loops back around, you'll see them very well in the upper left. There they are. Those things are very cool. And you can see the related prominences over on the red image.
It's fabulous.
So yeah, the sun's very active right now. That one, the yellow one, the center. It's just I love how it's just boiling. That's very cool.
Can we see spots on them right now on the regular?
Let me get to a different window up. to daily
I would
data.
suspect that one it'll give us something, right?
Done now. Yeah, I'm looking at the HMI image right here. Data links. 1096. Yeah, there's a little something there. All right, let's share that again. Share that screen. Okay, so I'm going to just
Yeah, there are a
that
couple.
one
How
big.
about-
Yeah, I'll zoom in on that guy. Kind of small comparatively.
Yeah.
I don't see anything else hanging around there.
Yeah.
There's a little bit of discoloration over there.
Yep.
But yeah, that's pretty much it. There's not much else. That's the guy that was boiling in the
Yeah.
corona image.
Some work on the side, on the right side, that looks like that's pretty active up there.
Yep.
Where you were talking about the tornado type things, right? Yeah.
That would be over here, right
I
up
thought it was
around
on the-
that area.
Yeah,
No,
okay.
they were all swirling around up here.
Very cool. I was talking about that stuff on the very right side of it that was near the edge. That was really, really active as well. Okay.
I think those are called plages.
Is that what they? Yeah.
The effect you're seeing on the photosphere there.
Yeah. Cool.
Okay, thank you. Ria, do we have anything for the hands-on interest group?
No, unfortunately, not much, other than, to be honest with you, whenever we have a virtual open house through Doug Bach's observatory, people basically have been asking for different objects to look at, and if they're available, Doug usually will get to them and displays them on the internet for us.
So on the 28th, I figure I'll open up around 8:30.
Okay.
All right.
That'll be wonderful. Thank you.
Yeah. If it's
Okay.
cloudy, I don't know what you want to do.
Yeah, we'll use the cloud filter.
All right.
That's a super expensive filter.
Yeah, I was gonna say, can I borrow one? All right.
If it's cloud,
Okay. Dale Teamy, is there anything new with the history group?
History group's got nothing.
Okay. How about astrophotography?
Bill has been kind of absent for the summer due to activities, so I don't know what you want to do about that, other than to say that if you guys have any questions about astrophotography, we have many astrophotographers in this group, and I'm sure that if we had enough interest, maybe we could get together in a little special interest group virtually to talk about astrophotography. That would be one suggestion in the future state.
Okay, thank you. How about GLAC? Adrian would be the man for that, and he couldn't be here tonight.
Yeah, I was on the meeting with him. So other than the fact that we're going to be just doing live streaming this year and hopefully getting back to in-person event next year. But yeah, the board pretty much had the same opinion we had, and the fact that we came to the conclusion that it's really difficult to socially distance properly with telescopes. It just makes it difficult, and children are a large group of the attendees at that event, and nobody wanted to be responsible for getting any child at all COVID. So we're just like, no, not this year.
Okay. Any other group or report that we need to hear?
well, I'm still posting on Facebook an astronomy of the week. I'm getting nice returns on that. I'm utilizing mostly Sky Safari, and sometimes I get 30 responses, sometimes I get 2. So, and I've been highlighting different objects they can see or interesting objects. And right now, this last 2 weeks, I've been doing the summer triangle, using pictures that I've gained from Fred Espinac and others that illuminate what we're talking about, and we're starting to get some pickup on that So I'm going to continue to do that every week, Wednesdays.
Okay, thank you, Ken. And I saw Dave Levy waving his hand. I probably should have called on him earlier. David,
Oh,
you're
that's
on.
okay. That is okay. Thank you. Thanks, Dale. And for an observing report, I haven't seen any sunspots. That faint sunspot I've really been trying to see. I saw it a couple of days ago, but not since then. It's really very small. But there are a lot of prominences around. The other morning, it was Wednesday night, last Wednesday night, I was out observing Perseids, late Perseids, and I got a number of them, and including some Alpha Capricornids. And so that was very interesting. I did that session in honor of Carolyn Shoemaker, who was still living at the time, although she was very ill. Carolyn died on Friday, the 13th of August. And so for my poetic quotation today, I'm going to quote from Sevilla Martin's His Eyes on the Sparrow, words that I redid in 2014 to read thus. Whenever I am tempted, whenever clouds arise, when songs give place to sighing, when hope within me dies, I draw closer to the sky. From care it sets me free. My eye is on the sky, and I know it watches me. My eye is on the sky, and I know it watches me. Back to you, Dale, and thank you.
Thank you, David. Thank you very much. A fitting tribute.
Thank you. It's certainly is a big loss to the world.
Yes.
We've lost someone of the stature of Carolyn Shoemaker. In fact, for those of you going to the league meeting tomorrow, I will be giving a brief lecture about her. It's called, Did Carolyn Shoemaker Have a Sense of Humor? And that I'll be delivering tomorrow at 3:50, I think, Eastern Time.
Okay, thank you. Something that we do not always do is have a little time for ask an astronomer a question. So does anyone have a question they would like to ask? And I will give you a moment to think.
I have an observational report.
I have
Okay.
one question. Go ahead, Doug.
Okay. So earlier I said I only got out the one night, August 1st, and this happens to be the second object that I tried my new camera on. The 2600 is the Bubble Nebula. This is about 4 hours and 45 minutes. The Bubble Nebula is also known as NGC 7635 or Sharpless 162 or Caldwell 11, and it's an H2 region emission nebula in the constellation Cassiopeia. This is a hard object to get because of how spread out it is, and the magnitude is 8.7 spread out across this entire area. But what was cool was the fact that I compared this to a Bubble Nebula shot that I took last year with my 071 camera, and I got more nebulosity out here in less time with this newer camera. So I'm kind of pleased with how that worked out. In
Do you
addition,
have the other image handy? I'd be curious to sort of, is it apples to apples, or is the different integration and it's
different integration. The other one's 10-minute subs. These are 5-minute subs, but yeah, I can show it to you here.
because I've been curious. I know you're one of the people who've, it's the same sensor size but newer
technology.
Yeah, how much better, and I'm hearing that you're liking it, but what's the
here's last year's shot. This was 370, a little over 6 hours here. These are 10-minute exposures on this one. This is from last September.
Yeah.
Okay. All right. And that's
Can you show us the new one again?
Yeah.
Wow.
a little bit different.
That's really
Sharper too. Smaller pixels, I guess.
This one's the smaller pixels, 3.7 microns. This one's 4.78 microns,
Oh, it's not
which
that
shouldn't
much.
make any difference. Which shouldn't make any difference because it gives me a half arc second per pixel anyways. But these were 10-minute subs, and these were 5-minute subs on the new one. And there's actually quite a bit of difference when you consider I was taking 10-minute subs and I took over 6 hours on the original.
Yeah. No, that's
And this was in Bortle 3 skies, and this one's in Bortle 5 skies. So it's more sensitive. I got more of the H2 regions out here than I did in the other one without pushing it. So that was kind of an interesting experiment. So I'm looking forward to using it over the next couple of years here when I get a chance. In addition, I spent 10 days up at Boone Hill Observatory, which we were clouded out every night, except for about 2 hours one night, and I saw about 3 meteors, and that was it. And we went through storms 2 nights and lost power for 6 hours, but it was fun to get up there. It hadn't been up there since last year, so that's my report for this month.
Okay, thank you. I'm sure we'd have some observations from Adrian if he were able to be here tonight.
I have an interesting observation and some more regular observations that I'd like to share. So I saw my first large fireball the other night. Did anybody else see that?
Is that the one that was centered over Ohio?
That was.
Yeah, we saw it at Addison Oaks on was it Saturday night?
Yeah.
Yeah,
I reported it to the
green.
American Meteor Society,
Hmm.
and it took them a while to sort of respond. But after a couple of days, they said, "Hey, this, we've logged your report, and you and several others, and it turns out it's over 100 people have reported from. This is the map that they've given of their reports. But I'm up here in Port Huron, and it was 170 miles away. I guess this is like the terminus here. So, and what I reported was actually fairly on, because I was out in my backyard collimating my telescope, and I was sitting out there just working on it for hours because it was way, way, way off. And it just lit up the sky as bright as the moon. So it was the largest one I've ever seen by far. And I saw several chunks break off and burn up separately. No sound. It was too far away for that, but yeah. So I also got out and did some imaging over the last weeks here. The Eastern Veil Nebula, and I did a little bit of the Western too. This is 3 nights worth of data. What? I don't know how many hours. 12 hours, maybe? Might be 18 hours I got on this. This program, the scope. I wanted to get deep. I wanted to see some of these faint areas here down along the side. So it's the same camera that Doug has, the ASI 2600 MC Pro color. I did use a duo band filter for the blue and red, the H Alpha 03. And I also later I started a session. I only got one night, and I didn't bother doing a whole lot of processing because I had this dewing and streaking on my lens. Actually, I don't think it's on the lens. I think it's on the camera window of the western portion and the Pickering's triangle here. but I almost didn't even post. It was like, you know what? This is actually really good data. One night, about 4 or 5 hours worth, really clear. It's just a shame. I think I'm going to go back and make a new flat and see how much I can get rid of this. It might really almost totally disappear if I get a good flat out of it. It'll be, a week later, but I haven't touched the setup other than I've removed it from my mount. But yeah,
It's interesting how those streaks are almost look like they have less noise or something. I don't know, maybe it's just less light made it through or something. I don't know. Kind of
well, the water maybe wiped down some of the dust. I don't know.
yeah, maybe time
You
to
want-
clean a filter or
I don't see how flats would cake those out unless the dew is still there in exactly the same position.
Well, I wonder. It's a good point. Maybe it won't. I haven't removed the camera from the scope. I just took the whole assembly off and I put my SCT on for planetary, and that's what I was talking about. I was spending hours collimating it. It was way out, but we'll see. I think my camera is getting some moisture inside. I need to disassemble it, and there's these little desiccant tabs that you like put in the microwave to. I think moisture has creeped in there. I don't know if it's on the outside or the inside or what. Anyway, investigation. Nonetheless, even with the defects, I think it's a nice shot and my best one yet.
It definitely is a nice shot.
The Western Veil there. So.
Do you turn the anti-dew heater on?
I do.
Okay.
I always turn it on. So I don't know. Maybe I cooled it down too quick. We have been hitting the dew point pretty, really high humidity here. So, hey, it's Michigan. You're gonna get dew.
Yep.
And the last photo I took I spent about 4 hours on. My first picture of a planet in about 10 months. I still think I have some work to do on collimation, but it's the best I could do for Jupiter. So it's the backside. You can see the great red spot would be down here if it was that side. So I don't know where it is, but I call it the back. I don't know what you would call it, but it's the side opposite the great red spot. You call that the front. So
yeah, you can see.
I want to do more work on collimation. I think I can do better than this. Actually, tonight I might go out after the meeting. Let's look.
Do it now. Do it.
Yeah.
Get that EO transit for us.
Yeah.
Yeah, you're gonna almost talk me into doing that myself.
Yeah. So
you can almost see it looks like Opal BA, Great Red Spot Junior.
Is Opal BA down here?
Yeah, I think that's it right there.
Yeah, and then some of the other cyclonic storms.
Yeah.
Down through here.
My problem is half my equipment's still in my truck.
Well, my 11-inch scope hasn't been on since like October, I think. I took it off after Mars, and I got this new. Well, maybe as long it might have been on through like Christmas time. I got this new refractor, and I've just been really enjoying it. It's really sharp. Really, quite frankly, far easier to use than the SCT. But when I took the Hyperstar off, I guess I didn't get the primary down set in the notch properly, and the collimation was about as far off as you can imagine. It was jokingly off. It just, yeah. So anyway, that's my report. The fireball was really interesting, and surprisingly, I got a number of good nights in the last month to actually get some good imaging in. So here.
Just make sure your secondary holder isn't coming loose in the corrector plate. I've heard of that happening quite a bit.
The big giant screw, like the 3-inch screw.
Yeah,
that clamps it down.
The hole with the flange that you got a retaining ring on the backside.
Oh no,
that'll come loose sometimes.
I had Hyperstar, so I put the secondary in, and it has that tiny little notch. Mine is so small you can actually put it not in the notch pretty easily.
Oh, okay.
And I think I just didn't have it settled in there very tight. So when it was so far off, I unscrewed. It's like, oh, well, let me set that down in. That helped, but it still was way out. So anyway, I don't think I'm very good at collimating anyway. So I don't know if someone want to give me some tutorials. Also, it could use a cleaning. I'm certain I could get better out of this scope, but I don't know. I can't blame the seeing if my collimation's out.
Okay, thank you.
So that's what I have. Yeah, thanks.
Okay, so I think there was a question someone had. I forget who had it.
Hey, that was me. That's kind of a dumb question, I think, but I read today that Saturday we should be Pluto is basically directly above the moon. I've never been able to see it. I'm wondering if I can use my 8-inch Dobbs reflector to is that strong enough to see it? Do I have a variety of lenses, like down to like 4mm, 5mm, but I've never tried to even see it. And I figure because it's above the moon, I'm like, I don't want to blind myself. I don't know how much the moon's going to really wash out, any possibility of seeing.
You're talking about Pluto?
Yes, Pluto.
Pluto doesn't get any brighter than 13.65 magnitude and as dim as 16th. So that gives you an idea of how dim it is. Secondly, it'll be tough to determine whether it's a star or the planet itself, or dwarf planet itself. Just to give you some expectations.
So I need a better scope, a bigger scope.
Something you want to observe over a number of nights.
On a full moon, yeah.
Yeah, and a full moon is going to hinder that because it's going to reduce your visual magnitude. Right now, planetarium software is showing magnitude 14.3. You'd have to be under awfully dark skies, maybe out in Arizona with a 10-inch.
Okay.
You sketch it over the course of a week.
Yeah, and the way to
longer exposures.
And the way to detect that would be an exposure one night to see if you can see any motion, or over several nights, or observing is over several nights to determine which.
I saw someone recently posted a video, and he did like every 10 minutes he did some imaging, and he over a 2-hour period he showed motion of Pluto.
Yeah,
and I was surprised. I thought you would need days, but he had a 2-hour window, and it moved a little bit. It's like, well, there it is.
Yep.
I've never seen it. I'd like to. I have such a small window between trees. I can't even image for 2 hours.
I was fortunate in 1974 to see Pluto through a 52-inch that Michigan U of M had here before they moved it to Arizona or wherever it ended up being. And that was at the National Convention in 1974 at East Lansing. I was a member of the club then, and we went on the field trip to look through their 52-inch, and I got to see Pluto through that.
I'm sure our main presenter tonight probably has seen it through one of his.
Probably.
But that's one of my goals, is to make a nice little video. I'm probably going to have to move my telescope to do it, or I've actually been thinking about getting a Dobsonian. That's, if I had to ask a question, is like, does anybody have an 18-inch Dobsonian I can try out?
Yes, I do.
Do you? How transportable is it?
It's up at Boone.
Oh, maybe I need to make a visit sometime.
Yes, you should.
I should.
Dave?
I gotta say, I've seen Pluto. I saw it in the 1980s. And the interesting thing is that the person who was visiting me at the time, who also looked at Pluto through my telescope, was Clyde Tombaugh. So I got to show him his planet.
Fantastic.
Wow.
Yeah.
That's awesome.
Well, listen, you guys, I think it's time for us to take a break. You're welcome to continue discussing, talking during the break. And let's reconvene in 20 minutes at 8:45, and then we'll have our main presentation. Okay?
Thanks, Dale.
Please be back at 8:45.
Okie doke.
All right, in private discussion, I didn't want to do this before, but I want to do it now. NASA just spent, I was talking to Riyadh about this, NASA just spent $1 billion on developing a spacesuit to go to Mars. They just continuously amaze me at the waste of money that they do. If they took that $1 billion and placed it into some type of a robotics and put the technology up to that point, it would be such a better use of dollars. And I just they just continually astound me that they just will not spend the money in the most efficient way. And I just thought I'd mention that. You guys can comment on it if you want or not, but they continually to appall me as to what they're doing, like with Elon Musk and all the satellites and all that other stuff. They need to do better, and that's my feeling. I'm sorry.
Well, how much are they spending on robotics? I mean, you say 1 billion, but you know.
Well, here you go.
What's on the flip side?
Let's talk. I'll tell you exactly. That's a good question, Dale. Absolutely. The fact of the matter is NASA spends 95 cents on every dollar spent on keeping humans safe in space. So
wow.
95 out of every dollar, of which could be directed to robotics and advancing the robotics capability to do things that humans could do if they did that. But they don't want to do that because it's no romance in not spending people to Mars. And I just think that to put the people under a 2-year risk of losing their lives to solar radiation or whatever it is, and the expense of trying to land a big ship down there and taking all their food and all their water and all their air with them, I think is an unnecessary exercise, which could be better spent at exploring Mars with some really good robotics, much better than the ones that are here. And that's my feeling about it. I just don't think we're going anywhere in space. Because let's say we do go to Mars and everybody goes, hey, we went to Mars, we put people on Mars. Understanding that we went to the moon, not for scientific study. We went to the moon literally because it was a race with the Soviets at the time to get there first. And then they did it several other times afterward because of the same issue. Going to Mars isn't a political thing. And going to Mars, if you're going to explore it, you want to explore it with the most efficient dollars that you can spend. Where are we going after Mars? Are we going to the moons of Jupiter? Tell me about the moons of Jupiter. How radioactive are they? How difficult are they? Would we want to land a human being, let's say, on Europa and so on and so forth? My thought is, and you got to get there and back. You got to get there and back. And then after Jupiter, are you going to Saturn? I mean, you're talking about a double the length there. So you're already talking about, even if you advanced your speed, okay, you're still going to spend several years in space there and back with only several people because you can't take too much weight and everything like that. And you're not going anywhere. You're going to go to Uranus. You're going to go to Neptune. You're going to go to Pluto. Are you going to go to Proxima Centauri? I mean, talking about how fast do you have to go in order to make that even a reasonable trip? And is anybody going to want to spend their lifetime on a ship going there where the information coming back isn't really going to be productive? And what are you going to do when you get there? And that's the closest star. So my problem with NASA is, yes, space exploration is very, very important. And the people that tell me, well, humans like to explore, doesn't work in space as it does like on the Earth, because you have a problem with a thing called physics. And if you could break the laws of physics, everything's out the window. Everything is possible. I don't think you can break the laws of physics. And that's my thought about it. And I just thought I'd pontificate about that a little bit. And that's my feeling.
Interesting thought. I didn't realize it was such a high percentage like that, 95%.
It's huge. That's a huge percentage of putting money into something that could be better put toward, that electronics technology advances hugely as we go through, does it not? Can
Oh,
you
yeah.
imagine if you could spend 20 times the amount of money on the technologies?
Imagine if we were launching, the Voyager 1 and 2 this year, if the planets were aligned like they were back then.
Right.
Those opportunities with today's sensors and communications.
Exactly.
How much more science we could do.
Science. You're right. That's what my issue is that how much more science would you have? And I think you would have legions more science. And then you want to put humans in space for what reason? It just doesn't
Also,
make sense.
the talk that Gary Ross did a couple months back, about going, his list of underexplored regions. If we spent that money to do, send something out to Uranus and Neptune, send something specifically to the moons of Saturn, send something specifically to 1, 2, 3, some of the moons of Jupiter, whatever, landers and so forth. If we 95%, if that budget we could launch, multiple missions to multiple planets.
Absolutely. And if the studies that are done and so on and so forth, then you can even get to microelectronics and perhaps take a shot at getting to the nearest star. It would take many years, but if you could get it small enough and fast enough, you could probably cut it down to 30 or 40 years, perhaps. And if you could cut it down to 30 or 40 years, it makes sense for us to explore. I don't have a problem with that, but that's the closest star. So you tell me.
The interesting thing, and this sort of comes from science fiction,
Sure.
but I think it has parallels in science fact, is, people on some of these, movies or TV shows or whatever, they get launched to go on a mission at, current technology and current speeds, and they want to go to a different solar system, different planet, whatever. And 5-10 years go by and they're still on the mission, and suddenly back home they've developed new technology for speed, and someone, and 30 years later someone could launch and in 1 year get the same distance they did in 30. And it's like, well, why did I spend 30 years of my life traveling when I could have just waited at home and then spent 1 year?
And there's the other factor in using technologies. Again, like Dale, you hit it right on the head. If we got more inept, and we did, and we sent people out there, we could send people out there and they pass them because they're going faster. And what are you going to do when you catch up to them? What do hi there,
you want to hitch a ride? Bring your food and come on.
There you go.
We'll pull up the Reese hitch and grab your spacecraft and take it along, right? We'll use it for storage.
And then we talk about the surface of Mars, for example. It's got this perchlorides, which you can't plant anything in because you can't. It's poison to human beings. Even the dust from Mars could poison you if you just took it up the spaceship, the space suit off in your ship. You're talking about so many risks that we could do better without sending humans there. And that's my feeling is, again, I think space exploration would be wonderful for humans if it was practical. And I just don't think it is. Certainly not with the technology we have now.
I like your idea, and I'm, like I said, I was surprised at that, but I just don't see it happening. I don't see, by that I mean I don't see NASA drastically reducing.
Oh no, that's my issue.
For one, in some ways, maybe it's their reason for being. If it was just robotics, maybe they wouldn't need NASA. Maybe they could have some, private company do. It's like, oh, I guess we don't need the NASA administration. We're all about human spaceflight versus, satellites and robotics. But
I understand all the arguments for it. I get it, but I just don't think at this point in time it's a practical thing to do. That's my feeling, and everybody is entitled to their own feelings on anything they want to do. I just think we could do much better technologically than we're doing with humans in space. Even humans in low Earth orbit are at risk. We already know that. They're at risk from cosmic rays. They're at risk from we have this place called, what is it called? The one in that's between Africa and southern Atlantic, a radiation area. It's a concentration of radiation that sits there, and when spacecraft go through it, they have to shut down the spacecraft electronics, or else they get blown out. That isn't the space station. Yeah, well, that's called the Atlantic anomaly. That's what it's called, the Atlantic anomaly. Look it up, Atlantic anomaly, and that's another issue.
Not on the surface. It's only in orbit.
It goes from the surface on up, is what it is. But but it's not. If you're below the regular atmosphere, you're okay, supposedly. But that Atlantic anomaly goes into space. It's like a fountain that kind of threads out, and it goes from the coast of South America to the coast of Africa. And it's a problem for the Hubble, and it's a problem for the International Space Station. Now, some of them don't go over there when they go there. They go the other way. They go above it or whatever it is, or perhaps even below it. But if they go through it, you do have an issue. And you can look it up. Atlantic anomaly, it's called.
So here's something I've been thinking about when you mentioned Hubble. So, they're talking about putting up the James Webb. They've been working on it for years and years and so forth.
Yep.
And the Hubble is getting older and frailer, like we all are, And we have a lot of observatories for various purposes and various spectra in orbit. Surprisingly, far more than what I originally thought. But
it's amazing how much we've done. Yeah, a lot.
Do we have a true replacement for Hubble for when it does go kaput and they can't use it anymore? For the visual spectrum for pretty pictures, James Webb, isn't that mostly infrared?
Mostly infrared. But again, the point is that it does do things that Hubble can't do. So
well, and I have no problem with that. And the more the merrier. I'm just saying, if Hubble dies, we have a hole. We're missing the visual spectrum, which is in many ways the people's favorite. People don't go ooh and ah over
we're getting to the point
X-ray stuff as much. The scientists love it. It's giving us incredible data, but it doesn't sell science. Sometimes you have to sell it to the people.
Dale, the thing about it is that the Earth-based telescopes, with their capability of the sporadic, what do they have? They changed their way of doing it. It's a photography thing. I don't know. Somebody's going to be able to explain it to us.
Adaptive optics.
Adaptive optics. That's it. The adaptive optics allows these large telescopes on Earth to do what Hubble can do. They can actually do it. And the fact is, as we increase that technology, we won't necessarily need a Hubble for our regular stuff. And that's the area. But again, with the James Webb, you're going to have a lot more range of spectrum too. So, but again, I'm not going to argue that point. That's
can it cover the visual spectrum, James Webb?
Yes, I understand that it can.
Okay, I thought it started like halfway up and went.
It just has a little bit greater range. I don't think I'm not sure that it can do what Hubble does in the visible light as well. I'm not sure.
Yeah, it's gold plated. So.
Yeah. Okay.
Hey guys.
What did you say?
I just posted a link in the chat of the WebEx, and it was a really interesting read that I'd never heard of it. It's just basically a once every 10-year survey by the US Astronomical, Astrophysics Societies, or different orgs. It's called a decadal survey, and it basically plots out the next 10 years of what the US will fund from the James Webb Rubin.
We lost you for a second.
We lost you. Could you repeat that?
It just it was interesting because it's basically how James Webb got funded, Vera Rubin. It's basically the next they decide the next 10 years and they tell Congress, this is what we want. This is the recommendations for where science is today and where we hope to be. I'd never even heard of this decadal survey. It was a good read, though. I had no real clue that this was kind of how things get started.
You're
I have another.
My check
You're you're expecting the Senate and the Congress to understand science, I guess. Huh?
No, no, unfortunately, I'm not.
Ken, to answer the question about the spectral range for the web, it starts at 600 nanometers and goes to 28,000 nanometers. So it's not the entire visible spectrum.
Right.
That does clear that up. Yeah.
Yeah.
Still very, very good stuff, right? Okay, I've spoken enough. Get back to the meeting. Done.
How much time we got, Dale?
About 5.
Four more minutes.
4 minutes.
All right, Ken, I want to interject on your initial statement about, man versus robotic, and maybe just a little different angle.
Okay.
I can just imagine it over the next 10 years that the peripherals and like virtual reality and the line between human experience and simulation is going to blur to the point where you might almost feel like you are a robot with the right kind of peripherals, right? Like they're talking about all this stuff with Neuralink and all that. Just imagine where robots, you could get to the point where you almost feel like you're there. And what would be the point of, spending all the money on the logistics of sending humans when you can do it with robots and almost experience it like you were there.
That's what I've been driving at. As I think we can get to the point if we spend enough money on it, that we can't do what humans can do without the risk. That's my feel on it. And people agree with me, people disagree with me. It's fine. I don't have a problem with that. I'm good.
Yeah, and with the proper peripherals, you could democratize the experience too, right?
Yeah, sure. The Senate and the Congress are reluctant to spend money that they don't see during their elective period too. So what you're talking about here is they don't want to go into robots. They want to get somebody feet on Mars while they're still in office. Or something to that effect. That's my feeling about how they reflect on it. And that I don't think is in the best interest of humanity. It's in the best interest of the person that's in office. And that's a problem for me.
But there was a politician that used to say, "Beam me up."
Yeah, right. Yeah, there was one, wasn't there? Yes. That's cool. That's true. But again, like I said, whoever has a reflection on something different than I do, give it. That's fine. I just don't think that humans can treat travel in space like they can treat travel on Earth because of the physics involved. And I see Jim Shedlowski, my biggest nemesis in this area, coming right into the thing.
My perspective on this is I don't care one way or the other.
Probably that's the best one. Sure. And I respect that, Doug. I really do.
The only comment I would add to that is it's kind of a moot point to argue it. We're not in power.
Yeah, that's
maybe the way we solve this is we send Congress to Mars.
Well, I was.
That's a lot of expensive space
An
suits.
asteroid.
$1 billion
good
spacesuit.
I would gladly
Send all the
trade
way to
maybe
Mars. The moon is fine.
a few percent of our military budget for a science space budget and maybe education. I think that'd be a good trade-off.
Yeah,
I don't know.
I agree with
But that's
you
just me.
entirely.
You know.
No, that's a good thought. It really is. You're right. I think we're getting to the point, right, Dale?
Yes, I'm looking for our speaker. I'm texting back and forth with him.
Hey Dale, it's Matt. Can you guys hear me? This is Matt
Oh,
with
yeah.
PlaneWave.
Yeah, we
Yes.
hear you.
Perfect. How you guys doing?
Okay. Well, tonight, Matt Dietrich Am I saying your name right, Matt?
Yeah, Dieterich. Yep.
Dieterich is our speaker. Matt first tried astrophotography in 2006 and was instantly hooked on it, especially after he took an astronomy class. After finishing his master's degree in Geology and Planetary Science, he served as an Astronomy Ranger at Mount Rainier National Park. He was honored to have his astrophoto of Mount Rainier selected by the US Postal Service to become a forever stamp celebrating the National Park Service Centennial. I didn't know that. He also received his first NASA Astronomy Picture of the Day of the Perseid Meteor Shower over Mount Rainier. Currently, he continues his love for astronomy and technology by working at PlaneWave Instruments, installing telescopes around the world. And he's here to talk to us about that tonight. Matt, you're on.
Sounds good, guys. Well, thanks for having me and hanging out. I'm going to share the screen and hopefully pull up the PowerPoint. And I think it'd be great if you guys, it seems like you guys are obviously know each other well and are pretty interactive. So if anybody has questions, feel free to chime in. But I think um, if you don't have a question, then we'll make sure we mute our mics just so we don't get any feedback or anything along those lines. But hopefully, can you guys see this PowerPoint?
Yes.
Okay, perfect. All right. Yeah, so feel free to jump in, guys, if you got questions while we go through the talk. It should be about a 45-minute talk or so. And just like to go through a little bit of some of the cool technology that we have at PlaneWave Instruments, which many of you guys know has now moved to Adrian, Michigan. So now calls the state of Michigan home for our main manufacturing facility and headquarters. This is an aerial shot of the campus. This is actually just a little slice of the campus, and it's actually grown a lot since then. This was shot last year, and we've already added one brand new building that's going to house all of our small optical tube assembly, test assembly, and we have about a 57-acre campus now with a lot of buildings and room to grow. So I think that was the biggest thing that took us away from shipping everything between Michigan to California, because that's how the company was segmented. We had all of our machining and manufacturing in Michigan, and we would ship all the big optical tubes and components for final testing and assembly to California, where PlaneWave started. So that was going on for over 10 years. So you can imagine the expense that you would build up over a decade of shipping various telescope components, especially the 1-meter systems that ship in, 4, 5, 6 crates, very heavy and expensive. So we're happy to call Michigan home now. And, with this talk, we'd like to go into a little bit about some of the equipment. But like some of you guys know, we don't just sell to universities or government agencies. We sell to private customers that just love shooting through some of the best equipment available to astrophotographers and research astronomers. So I think that's one of the cool things about working for the company is there's never a dull day working for a small company that gets to deal with such a swath of intelligent people using fun equipment. I think it's a joy working for such a company and being able to help people facilitate some of their dream projects and dream observatories to capture the night sky. It's pretty cool. So that's just a quick sampling over the years of some of the colleges, universities, and things that we work with. Now, some of you guys might know a few of these products here. It's just a snapshot showing you some of the equipment, and likely many of you guys have even, I don't know if any of you guys came over. We had an open house 2 years ago. We didn't do one last year, but we definitely will have more in the future. But the 1-meter is standing there front and center, weighs about 2,500 pounds, 1-meter aperture, primary mirror. It is just a beast to install, and we could be on sky taking first light images within, it depends on the weather, but we could be doing it all in one day, a 12 to 15-hour day. Everything could be installed, collimated, aligned, and taking first light images all within one day. That same night, we can be getting images, which is pretty incredible. And The top left photo is one of our newest products, and it's piggybacked with a product that's going to be announced relatively soon that we've been working on. The piggyback on that is a Delta Row 350. It's our F3 Cassegrain OTA that is just an absolutely scary astrophotography rig, but also for satellite observations in wide field SSA, space situational awareness. If you're looking at debris tracking or anything in orbit, that wide field system is amazing. But it's piggybacked atop our RC 700, which that RC, the Ritchie creation we have, was designed for a lot of satellite tracking and on-axis research, especially with an RC where you don't get the greatest edge performance unless you start adding in correctors. But the RC that has about an 8,400 millimeter focal length native, it's impressive. It's f12 focal length, focal ratio, and a couple other systems. I mean, of course, we have OTAs, but that one in the top right is just for CDK24, and then all the way down to just smaller packages. On the bottom right is just a fully rigged out CDK14 on the L350 mount. If any of you guys have seen our YouTube or some of the videos I've also posted on YouTube, the one video we have shows some of the research going on with that rig, but also some installs and then just driveway astrophotography with an Altaz system that I did from Pittsburgh, Pennsylvania. It's the field derotator. You could just pull this thing out on a rolling pier cart and just aim it roughly south and build a pointing model. And within 15 minutes, you could be doing 5-minute unguided images with that system. Is what I was shooting back home. It's pretty cool. So just a quick glance at some of the scopes. As you know, astrophotography and for astronomy research in general, we're trying to really do two things when it comes down to it. We're trying to observe something with quality optics, right? Whether it's glass or a combination of glass and reflective mirrors. But you need to keep those optics stable, right? So those are kind of the two things that plagued me when I started astrophotography in 2005 and 2006. I tried sticking what was it? It was a film camera on the back of a Meade ETX 80. So it was pretty crazy to work with. So Laura was requesting to annotate the shared content. Now I haven't done that on WebEx. Is that something that I should approve, guys? Do you know?
Don't know.
Maybe
Do
I'll
what
just
you want.
maybe I'll decline it for now, just so we don't have any surprises. So, but long story short, we're always trying to combine quality optics with keeping those optics stable and tracking during long exposures. So when I would shoot with film, it obviously never worked with what I was trying to do, and it really taught me from the hobby of the perseverance and amount of things I needed to learn to actually take an image of the night sky. It was quite the learning experience trying to stick a film camera on the back of a Meade ETX 80 through the little flip finder thing. It didn't work. All the film came out bad, but it was fun learning and just being outside. So, we want to keep the optics with these great large camera sensors that are available now. We want to have really tight pinpoint stars. And of course, we don't want any fringing or any chromatic aberration and coma and these optical defects that come into play. You really want perfect stars. And that is extremely difficult to do, surprisingly. It seems so difficult, but it's because there's black magic when it comes to figuring the mirrors and creating a telescope that is holding the optics stably and isn't expanding or contracting when it shouldn't be. So PlaneWave really wants to try to solve a lot of these issues, right? The goal when our CEO and team of ownership back, a lot of them used to work at Celestron, they wanted to build the perfect telescope. And that is still our mission. And we joke about taking over the world one telescope at a time because it takes a while to make a quality telescope, but you get the end result of a product that is going to last for decades and is also going to provide you with incredible images. So the optics really show that, and of course, so do our new mounts that we've been producing. But we want to solve those issues for astrophotographers because we are astronomers and astrophotographers at heart and engineers. That's kind of what makes PlaneWave special. The CDK design, the corrected Dahl-Kirkham, it was pioneered by David Rowe, our CTO, and we've perfected that over the last nearly 2 decades. And the benefit of the CDK design is it's extremely easy to use and maintain, but it is also economical and relatively inexpensive to manufacture because you do not have hyperbolic mirrors. You're using a spherical secondary mirror. So basically, collimation is so easy because there's no preferred optical axis when you're dealing with a sphere instead of, say, a Ritchie-Creation, excuse me, a Ritchie-Creation that has hyperbolic mirrors. On the CDK-24 and smaller telescopes, we actually fix the primary mirrors. So, unlike SCTs, where you're actually moving the primary mirror to grab focus, our primary mirrors stay fixed. So that means you're not going to get image plane tilt or any deformation while moving the telescope. And of course, it's very rigid and stable, just the whole mechanics that we go through with expansion joints and everything with carbon fiber truss poles, really a well-finished system in terms of ease of use and ability to maintain the telescopes. And of course, pinpoint stars edge to edge, on these big camera sensors. That's the beauty of the correction, the corrective lenses at the back cell of the telescope, which is pretty cool. PlaneWave, if you guys ever come over and check out some of our facilities, we have in-house machining. We do 1 meter grinding. JD, the machining, he leads all that at Meridian in PlaneWave. That is our machine shop. And we've literally, it takes about, I think it's 100+ hours. We literally machine the back of a 1 meter blank piece of glass to lightweight it. So it runs for about a week, just diamond cutting the back of the glass, which is incredible. And that lightweighting really helps the rigidity of the 1 meter, and it also helps it cool down quicker. So, and of course, it could be lighter weight, so you don't need such a heavy system holding the mirror. But in general, the engineering team, the technicians, ownership, everyone at PlaneWave, the company is driven with a purpose to build such a great telescope, and we have a lot of talented people on board to help make that come true. So we're really fortunate to have a really tight team, and I think that's what makes PlaneWave really special, compared to other companies that I've worked with in the past. It's a joy for sure. A little bit more photos of the optical in-house capabilities. That top left is just working on some of the glass and machining it in one of the CNCs. The bottom left is during some of the figuring of the 1 meter blank. And if you could see the 1 meter, you could see there's actually this honeycomb of the back. So that is after it's been machined, it's face up during some of the figuring and the polishing stages. And then we've also come up with software driven figuring machine. So it's going to really work some of the high and low spots on the glass to give us more flexibility and throughput with the manufacturing. So that's an important thing of the demand is so high for these telescopes that we need the precision and the ability to use some of these robotic machines that we developed and wrote all the software for. So it's really a ground up approach at PlaneWave to make sure that we produce the highest quality instrument that we can.
Matt, question. Have you guys considered using the Roger Angel Keras Mirror Lab system to make your 1 meter mirrors? Are you familiar with the rotating kiln concept for honeycomb mirrors?
So I haven't seen that one particular, but I mean, of course, I've seen the one at UA down in Tucson under their football field. But we get our blanks.
That's what I'm talking about. Yes.
Oh, gotcha. I forgot the main name of it, but we haven't. We buy the blanks and we do all the machining from there. So the cost savings to machine them is leaps and bounds less than going through and taking all the glass and melting it and doing that way. It's just we've done all the cost analyses on it. It is orders of magnitude more expensive to do it that way, which of course we would have to pass on to the clients. And from a serial manufacturing standpoint, picture the Henry Ford model is basically what we do. We're streamlined in our manufacturing process for off the shelf equipment, and if we would do that, it would only add extensive expense to the 1 meter systems.
Okay, thank you.
Yeah. No, sure thing. In general, I mean, I know I'm touching again upon the CDK, but in general, the fast cooling, the fused silica, the fans, just the components, everything comes down to quality and expectations of meeting those for the end user, right? And that's one of the fun things about installing all these telescopes for everyone is I get to meet a wide range of people, you know, when we're in the field, whether it's for this shot, I took this photo at Brigham Young in Utah. We did a CDK 600 system for them, but it's so user friendly, and I love the CDK 24s in general because you have a 4,000 millimeter focal length and f6.5. It's just a light bucket and such a special system to work with on our direct drive mount, and you know, it's fun to shoot with. I think that's one of the benefits that I really like most. You know, going into some of the edge performance, you know, back when we still were able to sell the 16803 sensors, you know, that was the tried and true sensor, the 4K by 4K size sensor with 9 micron pixels people were using. And I wish someone would pick up and make that again. Maybe Sony or something with a CMOS would be pretty cool to have a square sensor again. But edge to edge, you know, field of view with tight, sharp pinpoint stars. Beautiful system with that CDK. That's one of the big benefits. You have tight stars in the center on axis, and then off axis, you also are observing that tight pinpoint accuracy of the optics. A little comparison, you know, on the left is just, these are some spot diagrams kind of showing you the performance. Once you start going off axis, you're really going to start seeing the benefit of the CDK. With RCs, you have a curved field natively, and then you're going to need to add, you know, corrective optics to it if you want to have any resemblance of off-axis performance. So the CDK really is designed to make it easy to use and to be able to fill large camera sensors with beautiful pinpoint stars. Some of the other cool stuff that we get to work on, of course, we have in-house software capabilities, and I joke saying that, well, we have Kevin Iverson. He's our software engineer, and he's one of the smartest guys I've had the pleasure of working with because he has the ability to teach as well as you know, work on such complex issues. I know sometimes that's a difficult combination, but he is very passionate about what he does, but he has worked through all the intricacies about PlaneWave equipment and has worked to develop, you know, our suite of direct drive motor control software to work with our new mounts. And you know, he's such an asset to PlaneWave that it makes it one of the other reasons why I love working for a company that has talented people that are passionate about astronomy. So with our PWI4 software, it's a tiny little screenshot on the bottom left, but PlaneWave Interface 4 is our most up-to-date software that controls everything from the 1 meter telescope to the L series mounts. So like our L600 direct drive mount, and then the L500, and then L350. So he taught himself direct drive motor tuning. They worked together to build this software. It's pretty special because the clients, you know, when we do the installs and balance the telescopes, because direct drive mounts, you need to balance them. And it's really easy to do when you follow the right steps, but then the benefit of the tracking you get out of the direct drive mounts is crazy. I mean, you're talking about, you know, 0.05 to 0.15 arc seconds of RMS tracking error. It's the stability is incredible, but the motor tuning is how you get that high accuracy in tracking. And Kevin integrated that in to PlaneWave Interface 4, which is our auto tuner, which is, you know, there's nothing like it out on the market for these direct drive mounts. You know, you either have a geared mount or you have a direct drive mount. You know, direct drive mounts don't have gears. But with this example, this was a screenshot from our L600 that I'm running down in Chile when we have spare time. It's on a pier down there at OBSTEC. But to give you an idea, this is a tracking graph. You know, you can see 0.05, axis is 0 is the right ascension axis down there in green. And then the green axis below that, axis 1, that's the declination axis. So 0.03, this is the tracking accuracy while I was imaging a dark nebulae region just last week. Now this little screenshot is just kind of showing the steps, you know, jumping into the direct drive motor tuning. Because when you send various amounts of power to a direct drive motor, eventually you get these harmonic vibrations, and you can eventually hear it. And so basically the mounts will sing. And basically the motor controllers, we're grabbing all the information off of that as we send various amounts of power. All that does is we can record the state of the motor, and we can optimize. Basically, it's like a PID. The proportional integral derivative, the motor control parameters. It allows us to make a motor work smoothly and track. So that's all integrated. We have videos on our YouTube. This is one of them. I'm not going to play it, but you can check out our YouTube to kind of see how the mount will go through the motor tuning process, the software side, because we want people to have the capability of doing this themselves. You know, we want you guys to be efficient in your work, and that motor tuning is important for tracking accuracy. Speaking of accuracy on the pointing model side of things, normally we see about 5 to 15 arc seconds of RMS pointing error. You know, all sky with our pointing model, Point XP, you know, and we can also do awesome polar alignment, which I love because when I'm in the field installing people's system, all I have to do is build a pointing model, something like 10 points, 15 points. It takes all of 5 minutes. And then I can see a RMS error of the pointing model telling me, hey, I need to adjust the altitude and the azimuth of the equatorial wedge to get polar alignment. So I do that and I offset the model, and all of a sudden I just live loop images in Maxim, and then I could go to a star and I just center it in the crosshairs. And next thing you know, I could have that polar alignment down to, you know, under, what is it, 30 arc seconds. So very tight tolerances, and we can get even lower, but at some point you're starting to get diminishing returns due to any flexor that you might have in a system. But all of the software is helping us achieve quality images, just like the optics and time we put into the optical tubes allows us to have beautiful optics, while the mounts are here to give us stable tracking and pointing precision in the long run. Now this mount will show this video. You can see one of our L mounts zipping around. This is at our old factory, but that's a L500, one of the early ones, and eventually it'll just kind of zip around to a few of these pointing model points. It's kind of funny watching it zip and move around. No gears, just copper coils and rare earth element magnets, for the direct drive motors. So I think the next ones we're going to cover some of the actual software. So the other integrated software we have is going to talk to the focuser. So you could do everything in terms of autofocusing, operating the fans on the optical tube to help cool everything down, and for actually controlling the dew heater. So making sure that nothing dews up. So PWI3 is doing that, and that's another piece of software that is all in-house and available. Now here's more action on the mounts. So a little bit of background photos. So on the bottom left, you can see copper coils. That's our azimuth motor assembly. You have copper coils on the base, and then you have rare earth element magnets that are all around it. So basically, it's just sitting on a bearing. So when we eventually send electricity to that, we can slew it and command it. And there's a red piece of tape on the very, very top, kind of this inner portion, but that's the encoder disk. That's an incremental encoder. The tape is still on it because you have millions of little X marks on it. Etches is what I meant to say. Millions of etches on this encoder disk that we can provide precise pointing and precision. So that's basically our feedback system. So we know where the mount is going to be pointing in relation to some mechanical hard stops that we have in place. But very, very beautiful systems, easily track satellites, track the space station without any issue. No backlash, no periodic error. Direct drives, easy to maintain, nothing to re-grease. You have a bearing that's sealed. You're not taking apart the mount to go ahead and re-grease, once a year to maintain it. Overall, more user-friendly experience, and quiet and very quick. Jumping into some of the smaller mounts, the L350, that's the smallest one that we offer right now. It's a capacity of carrying 100 pounds. It weighs about 110 pounds, but it can hold up to our 14-inch telescope. So that was the one that we used, kind of did some of the astrophotography from the driveway. You just carry that thing out on a rolling pier cart, just drag it out on the wheels, and just get set up running and imaging within a matter of minutes. It's pretty cool. This shot was done by one of our PlaneWave clients that's running with this rig, Kevin Moorfield. Feel free to check out his stuff because it's spectacular. That's an idea of what you can get out of the Whirlpool Galaxy with beautiful data on that rig. This is just showing more center and then edge of field of view, kind of tight stars going on with the CDK 14 on the L350. Tight stars, low full width half max, and beautiful stability on that one. Stepping up in size, the L500 mount, it carries up to 200 pounds. Same slewing capabilities. These are all using the same motor control electronics. It just really depends on how large of an OTA would you want to carry. This can carry that 200-pound payload. So it's one of the best-selling mounts because it's a sweet spot. You could be putting, a 17-inch telescope on the inside, and then you could put, like this client did, you could be putting a smaller refractor on the outside and doing some wide field imaging or visual observing like we did. And this is another one of the Triangulum Galaxy M33 here. Beautiful shot with, this was one of our other clients with the L500 mount. It's kind of scary what you do with that in the 20-inch CDK. It's stunning detail you can get out of the galactic core in the dust lanes. Pretty wild. Well, the big boy L600 mount that carries 300-pound payload. It's beautiful to install, and it's very easily installed, especially with a crane. It makes it so much easier to lift that sucker in and install it and get set up. But we had an Adler Planetarium install in Chicago. We did the CDK-24 on the inside, and we did a Takahashi 106 on the outside for them, just so they can have some wide field, observing and astrophotography with it. All right, so here's one test example. This was a system we put up at OBSTEC in Chile. This was our CDK-24 and L600 mount. And, I put one of these Sony sensors on it. It's a QHY600 using that Sony 61 megapixel camera. It's crazy oversampled. My plate scale, bin 1x1, I think it's like 0.19 arc seconds per pixel, but I've been at 2x2, obviously just because the file sizes, at least, are somewhat manageable. But the detail that we're getting out of that system, I was figuring that with those small pixels and the high megapixel count, that it was going to not look great. But this is pushing the boundaries. I think that's one thing fun that we can do at PlaneWave is put this equipment up under dark skies and shoot. And this was only 2 hours of luminance, to give you an idea on that sombrero shot. 2 hours of luminance and 30 minutes of RGB. That sensor is special from Sony, and it's backside illuminated CMOS. It's just very sensitive to use an image with. Stepping up is the CDK 700. Some of you guys have seen this. It's been around for a while, tried and true at research universities, but also public locations where they want to do a mix of imaging and also observing, because we designed it for ADA compliance. So basically, someone could be sitting in a wheelchair, and due to the dual Naismith optical design, you could be sitting there and have the eyepiece right at eye height for someone that's sitting in a wheelchair. And that's one of the great benefits of dual Naismith, is you don't have to swap equipment. We have a tertiary mirror inside the optical tube that rotates 180 degrees to put the light out to one port or the other. Very flexible, alt-az system. We have them installed all over the world. Case in point, this one we installed in South Korea. This was for a public observatory, and you can see the big flat panel on the wall that they'll use for capturing their flats. It was pretty funny to see, but a beautiful system. Well, the other 700 system I mentioned is now the RC 700, the Ritchie Creation 700, mainly designed for the folks that really need on-axis performance. High focal length, 8400 millimeter focal length, f12. It's going to be great for the people wanting to do laser communications, with satellites, for researching space debris, in SSA and SDA, space situational awareness and space domain awareness in general, observing everything that is orbiting. And of course, there's a lot of space junk up there. So there's a lot of more observations that need to be done to classify all this material that could damage satellites. It's pretty serious now with how much stuff is up there. But this system is designed, and we've sold numerous of these, and just recently we did an install at NASA Goddard. They're using it for laser communication testing, and it's pretty special to see that system going to them. Here's a fun one. You guys will like this. So this was the factory acceptance testing for NASA. This is a space station. We're using our software that Kevin was working on. He could recenter. He had a wide field system up top, and there's a space station. It was so bright, it collects so much light. We didn't have time to dial the exposure in, but you could just see that's 8400 millimeter focal length, so 8.4 meters of focal length. and that's the tracking. And eventually we'll kind of grab a point, and the azimuth axis is going to rotate. It just goes there, and the azimuth axis will rotate around after it transited across meridian. It'll come back and grab that space station again during its pass. So they are going to be communicating with satellites, and that wide field system is going to help them acquire and then center on that high focal length. So it's just crazy cool to see, but I definitely want to shoot that again. It'd be really fun. Kevin did a great job with that pass, just special for that kind of night. Well, last but not least, on the big side is the 1 meter. So we craned this guy in multiple stages, and we could be up and running, as I mentioned, within that same day. You know, a lot of times it turns into a 15 to 20-hour day, depending on the weather, but we're up and running for clients that night, taking photographs of galaxies and nebulae for testing. It's just a special system. You know, there's no other company like it producing them in such quantities, and with successful installations like PlaneWave. It's really special to see how many of these institutions are using them, but also private clients. A lot of them are using them for astrophotography and visual observing. So it's a beautiful system, absolute encoders, you know, direct drive rotators for all the field derotations, and of course the dual azimuth again, so you can have numerous instruments on the system and flip between them with a flip of a button in software. Well, we could jump into probably some of the pretty photo stages finally. I know most of you guys are probably waiting for that. Kevin Moorfield again with the CDK14. I mean, he did so many hours of data on this, but the pillars of creation and the Eagle Nebula are just crazy, beautiful and clean that he did with that. CDK17, Martin Pugh and Mark Hansen did a beautiful job. Martin Pugh runs that 17. It's just very crisp data that he gets out of that. You can just see all the structure in the horse head is pretty ridiculous at these shoots. The CDK20, Don Goldman, you know, just such a great astrophotographer. But that CDK20 is beautiful, bringing in the narrowband colors for the rosette. Looking into the core of it looks pretty ridiculous. I love all that nebulosity. CDK24, that's always a beauty. This was Mark Hansen again. His editing is just spectacular, but that planetary nebula is pretty ridiculous as well. All the detail he gets out of it is so beautiful. CDK700, I mean, it's used for a lot of research applications, but also for observing and for astrophotography, but just some of our friends over at NARIT in Thailand. But basically, this is just a couple planetary shots that they did. Good seeing. They got some pretty good seeing over there in Thailand. Now we have a big boy in Chile at OBSTEC. One of the most fun places I've had to install telescopes is there, and an incredible staff. I mean, you can see the data quality that Mike Selby shot with this. This is his 1 meter down there, and we're going to be, you know, sharing more data, you know, with that. He shot some narrowband data that he let me share and edit. So I worked on this, and I was trying to get a workflow down to get in the Hubble palette, and it's how clean that data is absolutely scary. Shooting through it and then playing with it in PixInsight and Photoshop was some of the most fun data I've ever edited. And you zoom in and there's no noise. So much light is reaching that 16803 camera sensor, and that's, you know, still CCD technology. It's not even CMOS, and these CMOS sensors are so much more efficient. I mean, you have the differences between CCD and CMOS, but the performance and the sensitivity out of CMOS nowadays is, we're going to see a lot of incredible shots, and we already are seeing that now with CMOS. Now that a lot of the CCD manufacturers have stopped making the big sensors, but that was again from OBSTEC in Chile, just under great skies. Now, a big piece of, you know, what I've done with PlaneWave for the last 3.5 years was, you know, work with clients on making sure that their equipment gets installed and that they get trained on how to use it and get up and running that night. You know, it's important that people get trained on this equipment and technology, because it's very high performance. So it's been really fun to work with clients and share the equipment with them. You know, while we do the installs, I've made such a lot of special relationships, and you learn a lot about people when you spend 15-20 hours with them building a system and putting it together. You build these bonds and these relationships that that I really enjoy when we're in the field doing that. So I really like that aspect about installs. This is some of the behind the scenes. On the left, this was a shot we did for McDonald Observatory. I was working on, we did a PlaneWave astrophotography workshop. And as a company, we're going to be doing more of those workshops. And I've loved helping, facilitate a lot of those in the field. But we'll be doing more of those for people wanting to learn astrophotography and night photography in general. But that was an L350 mount carrying our new Delta Rho telescope under the Milky Way at McDonald. And on the right-hand side was the install we did at OBSTech it was end of February and March of this year. We went down to Chile and installed a few systems, but I like capturing those behind the scenes views so I could share the experience of being under the night sky working with our equipment. In 2021, it's been a crazy busy year, but some of the big notable installs that I look forward to so much was we went down to OBSTech in Chile, and if any of you guys don't know that company, they are doing such great work. It's ran by PhD astronomers. It's a remote hosting facility, so if you want to put equipment down there, just let us know and we can help you guys facilitate that. But then you can log in on your phone or on your laptop and just control your remote observatory. And the skies down there are jaw-dropping. So we put together 2 CDK 600 packages and 1 meter. So the amount of systems down there is just ever growing, and that was probably my favorite install so far of the year because I had to be down there for 2 weeks due to the COVID protocol. You couldn't leave the country for 10 days. You had to be there for at least 10 days. So we made the most of it, and we installed 3 systems, and we're up and running, capturing all those images that you saw. Another very historic one that I look forward to, it was this past June, we put a 1 meter for MIT and Caltech at Palomar. I'd never been there before, and it was such a joy working with everyone, the staff, everyone helped put this sucker together. And that was one of the ones that was about an 18 to 20 hour day getting everything done because the dome was very small and they wanted a very tight form factor, and they had that dome available. So that's what we installed it in. But in the background of that photo I took with the drone on the top right, you can see the Hale. That's the 200-inch Hale telescope in the background of the force has made such numerous amounts of discoveries over the last 50, 60 years it's been operational. It's pretty ridiculous that the thing's like the size of a house. I mean, it's huge, absolutely massive telescope, but just fun to be a part of that site and continuing the tradition of stargazing and research there. Oh yeah, I forgot about this one. So any of you guys have heard of our Delta Rho? This is our F3 350 millimeter aperture Cassegrain telescope. This is what we took down to McDonald Observatory, and you can see the images that I shot in 2 2-minute subs. The top right, 3 2-minute subs. There's your Lagoon Nebula. The bottom right, there's a Trifid shot. This is coming soon, so there's a lot of hype already because people know about it, but the quality of the images are just scary. And I paired this with that Sony sensor again, that 61 megapixel. This was in the ZWO body. It was that 61 megapixels, and I was running 2x2 binning the detail out of some of the objects. I was shooting some different galaxies. We did the we did M51, and zooming in on the detail is kind of scary what you can get. This is 1054 millimeter focal length, and to be able to zoom in with these high megapixel count cameras, it's just a match made in heaven for it. So a beautiful rig that you guys definitely won't want to miss out on. But another cool thing that we got going on is the 1 meter telescope. The 1 meter down in Chile, we're going to be putting together data subscriptions for it. So if you guys just want access to the data, we'll be putting together that in the near future. So you can use your phone. If you use your phone or just go to our website, you can always sign up for a newsletter and just stay tuned for that because we'll be making announcements on when that becomes available. But on the right, that image of the sombrero was taken by Mike Selby and the team down there. So you can see the dust lanes. I mean, it's kind of scary, the amount of resolution this system can achieve. So that's one thing that's going to be fun to put together some data subscriptions for people to work on. And of course, it's down at OBSTech in Chile, so you don't get much better. I mean, it's usually 1 arc second level seeing down there, and sometimes it breaks under that. not far from the Gemini South Telescope and the Vera Rubin, which was formerly known as LSST, and Cerro Tololo. You're in the region of, some of the biggest telescopes on Earth. It's just a beautiful place to have remote hosting capabilities. But thank you. I added a few additional slides because I know Dale wanted me to bring up just a few points about some of my astrophotography, but in general, putting together these systems for PlaneWave and working with clients is so fun. But a little bit about my background with astrophotography. I started in 2005 and 2006. I finished up grad school and I always wanted to go work in a national park and teach people. And I wanted to obviously capture my experience under the night sky there and share that with people. So I did that, and some of the photography started to gain, some traction when we had Northern Light activity, and that was the one that the Postal Service picked up and was used for that postage stamp, which was just fortuitous. Ironically, my astronomy teacher in 10th grade said, "Start out doing star trails," and I didn't take her advice in 2007. I waited until 2015, and that was my first star trail shot. So she always gets a kick out of hearing that when I say that, well, I waited that long to take a star trail shot, and lo and behold, that one kind of really opened my eyes to how people view astrophotography as an art form and what we can do with it. I was so scientific with it before, and now I really learned that people look at what we do as a hobby, as art, and you can inspire people to get outside and just, it makes people happy. So I always try to let people know, don't just let your images sit on the computer, on the hard drive. Make prints, go to a coffee shop and ask them if you can hang some photos, something like that to get people engaged. The biggest thing we can do as astrophotographers and astronomers, we need to engage younger people. I mean, this is a hobby that's ever growing, and nowadays with social media, we have a huge advantage to reaching people all over the planet. And that's one thing that I wanted to do with my astrophotography. And these are a few images I captured in Chile. Just some of the wide field stuff. I love the wide field imaging to give scale to these targets, and these were a few that I shot from OBSTEC, just showing Rho Ophiuchi rising over the Chilean Andes. You can see that hydrogen alpha and reflection in dark nebulae, just crazy cool. And then, of course, kind of the core of the Milky Way, just a little bit to the side of it with Rho Ophiuchi, and all the hydrogen alpha is crazy. So that was a fun one to put together, and a couple more wide field shots. This was a 72 image panorama of the Atacama Desert. This was not far from ALMA, the Atacama Large Millimeter Submillimeter Array. You can kind of see the substation way on the horizon as a light dome up in the Andes there. But crazy air glow. You have zodiacal light to the right. Incredible Milky Way, and you're about 8,000 feet. It feels like you're in a lake bed at sea level, but you're really about 8,000 feet, because some of those peaks, those volcanoes on the horizon are 17, 18, 19,000 feet. It's crazy. So beautiful skies that I wanted to capture in that wide field panorama from Chile. And this one was fun. The Milky Way from an airplane, just a single 15-second photo of the Milky Way on a flight coming home from Chile, which is pretty cool, just setting over the Atlantic Ocean. You can put together really wide field shots and kind of make this fisheye effect, which is pretty cool. You have the Milky Way setting with zodiacal light and then a little bit of Gegenschein. But this is from OBSTEC as well. A crazy red air glow that night, just all around the horizon, and beautiful sight to work at and share the night sky. And then last but not least, one other shot from a national park from Mount Rainier that I used to work at. This was literally from the visitor center parking lot, so you don't need to travel far in some of these national parks. You don't need to get out the car very much to shoot the Milky Way. You could hike as much as you want, or you could literally take a step outside from the visitor center and shoot the Milky Way, just like this one from Mount Rainier. But just a little bit of I like sharing the wide field aspect. I feel like it gives relationship to the night sky, and then of course adding in deep sky astrophotography is such an added benefit to bring objects that we don't get to see with the human eye into view. So I really appreciate you guys inviting PlaneWave to be a part of your meeting today. And if you guys got questions, let me know. But as always, reach out. And maybe I'll share my email, but you can always reach out to us on our website if you guys need any help.
Super.
Awesome presentation. Thanks, Matt.
Thank
Yeah,
Matt.
for sure, guys.
Thanks, Matt.
Excellent.
Matt, I have a question. That photo you took out the plane window, how did you get it steady?
I should have
Like
put
suction
the
cups or something to the window?
I should have put the behind the scenes photo, because I it's on my Instagram. If you guys, if I don't know if any of you guys are on Instagram or any of that, but I put it on there like a behind the scenes of I learned a few times of how to do it. So basically, ideally, you could still see the red light, the navigation light from the wing, but you need to literally get under a blanket like you're an old-timey photographer, because there's so many lights inside the cabin. Even like the lights were out, people were asleep, and I'm there. I took my tripod and I pushed the legs up against and leaned it against the window with a 14 millimeter lens, and took a few shots. It took a lot. I mean, this was ISO, I don't know, 32,000 or something, and with that DA50, it gets noisy. But you want to tape. I literally was like holding the blanket with pillows all stuffed to the side to block light. Because any little reflections will bounce in the window of the plane, because they're like double paned in that. So it took a few, but yeah, a tripod was used for it, and blankets around the edges to try to block the lights.
Huh. For your new Delta Row, is that going to be lower cost than your 12.5-inch CDK?
Due to the manufacturing on it and the technology, it's going to be a little bit above it. Right now we're planning around, I believe, 15.95, so just shy of 16K, but it's a Cassegrain focus, right? So so you could put large cameras on the back without having to block the optical path, right? So compared to other fast systems that are available, you don't have to worry about like a filter wheel obstructing it. You could put everything on the back, Cassegrain focus with it. But yeah, it's just shy of 16.
Yeah.
Do you plan on offering anything for more amateurs, let's say?
There's stuff in the works. It just takes so much time to develop, but this was the one that we've developed more recently, because we've seen, and another one we're going to do is a 20-inch at some point, a 20-inch f3. It's one of the ones that we've been brainstorming. This is just shy of 14 inches, right? And a 14-inch light, dude, the thing's like this long. It's short. We are doing a smaller one. It's for some contract work, but we'll see how that pans out if it's going to go into the amateur market. But right now, that's something that we're still discussing internally, though.
Yeah, it takes a lot of means to buy some of your equipment, though.
Yeah.
What level, like system wise, what do you guys like? 16th wave or
As
like
a system,
optically? Just curious.
yeah. So the way, so we don't do it on a per mirror basis, because if it's a per mirror basis, everything's diffraction limited that comes out of our factory. That's what we always try driving home, because if the system as a whole is not performing to diffraction limited specs, it does not pass our quality control and doesn't leave the factory. So we test everything. Sure, we look at each mirror, but then we also mount the mirrors and we test everything as they are in the optical tube before they leave. So that's how everything leaves the factory after testing. Is diffraction limited, so everything is seeing limited, and atmospheric limited.
You guys use like a interferometry, or how do you test optics?
We have some proprietary methods and then software that we've used, but we do have some technology for interferometry for some of the testing with the faster systems like this Delta Row. Interferometry can help as well, especially with F3 systems and really fast mirrors that could come into play. But we have different methods that we do in-house, and we have test tunnels that we do all the artificial stars and all that, the optical testing of the mirrors as well, to do the actual analyses on the wavefront analyses in-house.
would you guys be interested in hosting like an amateur night where you can bring your scope and let you guys put it on a D-Pack or something?
That would actually be pretty cool. I would definitely have to talk to ownership and see, because that would be it'd be pretty cool. I know we definitely want to do more open house events and things. I know it's kind of tricky with the State of the Union as things are going. So I definitely want to do that, and we are talking, and maybe you guys would be a good one to brainstorm about doing. We want to do some astrophotography gallery kind of events, and then also some on-campus workshops, astrophotography and night photography in general, because I mean that's one thing that I love teaching and offering, and I feel like it helps bring relationships back into a hobby that a lot of times we're doing by ourselves, right? I think that's one thing that we're going to be adding on for next year, hopefully, is some more workshops and campus events and things.
Well, I don't want to speak for the club, but I personally would love to collaborate on that sort of thing.
Yeah. Well, I'm glad, because that's something that we're brainstorming a lot, because we're going to be building an observatory and putting a 1 meter up on campus. There's a lot of growth that we're doing and a lot of brainstorming, but just for the engagement side and the fun, because like I said, we love this stuff, and just want to get people involved. So I think next year we're going to plan like maybe that little gallery event, but then also some on campus maybe workshop events to do some teaching and editing. Editing is always something I can improve upon. I know that for myself for sure.
I have a question. Do you get much interest in scopes bigger than 1 meter? And if you do you have any thoughts of eventually going there?
No, it's a great question, and we've been working on the FEA, the finite element analysis of a 2 meter design, and it's eventually going to happen. It's a future event, right? It takes a lot of infrastructure. We need to have a new building just to do. We need to buy a greater than 2 meter flat to do the optical testing in house. And you can imagine if any of you guys have been to our campus to see our 1 meter and 0.7 meter optical tunnel for some of the testing, we have a 1+ meter blank, mounted to the roof at a certain height to do our testing to make sure that the system's passed final testing, and we need to do that for a 2 meter. So, but we have multiple amateurs that want one, and but also institutions, and so a 2 meter, I hope, because I mean it's a bucket list dream is to work and install on the 2 meter system for sure.
Is that like Elon Musk and Jeff Bezos that want those 2 meter?
Bezos ironically has a 0.7 meter of ours, but we need to joke to Elon to be like, hey, you need to step up and beat him out with a 1 meter or a 2 meter. But I don't have Elon on speed dial, so I can't just text him or WhatsApp him or something. But it's private guys that just have some of our systems. I mean, you build these relationships and you network with people. And they just want to push the boundaries. I mean, that's what we want to do as well. And they believe in us as a company to help them achieve that. And we're always here to listen and open the discussion for how to improve. And the RC700 was case in point. Industry wanted something for laser communication, satellite tracking. So engineering and sales worked to develop that telescope. And like we said, now we sold one and it's installed at NASA. For lasercom. It's we want to listen to what people want and learn how to put these systems together and in the highest quality that we can.
So, question about upper Midwest here, like, could you even utilize the potential of some of these setups with the seeing and the skies that we have here, or are most people installing these in like faraway locations with like premier seeing?
I mean, it runs the gamut, right? We sold a system of 0.7 meter to a Michigan university, so
Right.
they're being used, right? And that 0.7 meter is 4,500 millimeter focal length, f7. So they're used all over. It really obviously helps to have good seeing, but in terms of astrophotography and engagement, say if you're using it for public work, then the seeing is less dependent. But of course, even in Chile, I mean, you have nights of good and bad seeing, and down there, the bad nights of seeing are 2 arcseconds. So it's I mean, I live in Pittsburgh, Pennsylvania right now, and of course, what are we? Probably always like 2.5, maybe 2 to 3. It's just the nature of living in Pennsylvania, but I understand if for darkness and control of the system, a lot of people do put them remotely, but a lot of people are putting these in their homes and personal observatories, despite seeing.
Yep.
Well, Matt, it's been a pleasure. Thank you so much. We really appreciate it.
No, yeah, appreciate you guys, and hope you get clear skies for some of your programs and all that. I know it's been a lovely couple years already. It seems like with with public sessions and all that stuff. So hopefully that improves next year and moving forward. But again, yeah, if you guys have any questions or need any help, we're here to lend a hand.
I just got to save my pennies for your 350 mount. That's all.
If I had the money, I'd put one up too because they're so rigid and solid. They're incredible. That with like a 14, the data you get out of that's just scary. Yeah, they're beautiful.
You do offer a Michigan resident discount, right?
Well, yeah, we don't have to do the tax. No, I guess we still have to do state tax, sadly. So I was gonna say, could we try to save you tax? Because if it's outside the state, then yeah, but
Yeah,
I hope.
Penalty.
but
No, I'm talking discount.
Yeah, 5-figure discount.
Oh no.
I would just put my little 10-inch RC on it.
Yeah, yeah. They're beautiful systems though, and I mean, yeah, if you guys have any questions, definitely let us know and reach out.
Okay, sir. Thanks.
It's a great talk. Thanks.
All right, guys. Well, hope you have a good night and talk to you all soon.
Okay.
Thanks,
Good
Matt.
night.
See you guys. Cheers.
Right.
Appreciate it. Cheers.
Was that good or was that good?
Yeah.
It was excellent.
Yeah. Very good. Very nice.
Again, I got to save my pennies.
Yeah. So how much do we have in the treasury?
Oh, you could get one of those mounts. You guys got the money for the mounts. Yeah. Actually, you could get the 14th system. with
Yeah,
the money
the
you
mount
got.
and the 14th. Yeah, it's
Yes, you
$22,000.
Yes, you could get that. And that would be a very nice system.
Maybe you can make some money at the swap meet.
Yeah.
And if you can't fit it into your dome because you want to keep your refractor, I have a place that it could be located
Yeah.
and can be accessed remotely whenever you want.
Sure.
I got
If
the service
anybody
already.
PM'd him, but I've already tried to asking him if they're hiring.
Yeah.
I would. That sounds like a dream job, honestly. What he's doing, setting up telescopes all over the world and private clients. I mean, come on, that's a great job right there.
Actually, I visited there, I believe it was about 2 years ago. And they were trying to hire people. And their problem was the local university wasn't offering the courses that they needed people to take to work as engineers for them or as technicians. So they were working with the local university to try to get them to make some changes to prepare students so they could hire them.
Was that before or after they located Adrian?
This was 2 years ago, well after they located Adrian.
So Ann Arbor is the closest, right? U of M would be the
I would
closest.
assume.
Yeah, which is surprising to me.
Well, there's the Adrian College too.
Yeah, there's a local
That's a
college.
smaller private school, right?
Yeah.
I would
I
think
don't know
you
what kind of
have
program
graduates
they
would
have for
have.
astronomy or anything like that.
I'm retired. so I'm not
Albion's not
interested.
too far away either.
Yeah.
I'm retired, so I'm not interested. But I did real-time systems as a profession.
Yeah, I was just in the Adrian area. My aunt was a nun that died recently, and she was part of the sisterhood that was based out of Adrian. And it's very farmlandish, and I kept remarking, and I bet there's some great skies here. And I'm sure it's probably a good spot for a telescope manufacturing company.
Actually, the tour I went on 2 years ago, that whole campus used to be some kind of a school for wayward girls.
Hmm.
Like, I don't know, 100 years ago or some ridiculous thing like that.
Yeah.
And they still have a building that's being used for people to learn how to make, to do exquisitely fine wood furniture.
Like Amish?
Well, it's similar to what Amish would do.
Yeah.
It's very, very hands-on kind of stuff. And they had some ceramics stuff. I mean, PlaneWave Instruments was not running that stuff, but that stuff was on the same campus they were on.
Yeah.
For all I know, they owned the buildings, but just let it continue to do what they had been doing. So it's quite an interesting tour. I would recommend if they start having tours again, it's worth it to go on one. Plus, I went through their telescope manufacturing facility. Quite interesting stuff.
Yeah. I'd like to do that.
Well, I think our next event is a non-official event on August 28th, Saturday at 4 p.m. Hope to see some of you guys there.
Are you going, Dale?
I plan to. I have a guy coming to do some work on trees at my place that day. So I hope he comes early enough to where I can go to this thing at 4 o'clock.
I'm curious, is anybody a member of the Oakland Astronomy Club?
I'm sure we have people who are
We have
members of it. Bob Berta, for example.
Well, and I think John Panuto might be a member of Warren. So they're having their club picnic tomorrow night at Addison Oaks, which is where their observatory is. I'm it's probably going to be a game time decision for me. And it'll probably just be me, you know, I'm fully vaccinated, so I'm not so worried for myself, but I get, you know, where we're at as a country and county, and I'm looking at stuff as everybody else is. I feel like as an astronomy club, we're fairly well based in science, and we believe in science, and I feel like the vast majority, if not all of our members, are probably vaccinated. I know as a GM employee, we're mandating as of August, I think 24th, everybody's got a self-report. I don't know what they're going to do with that self-reporting, but my hope is that they just, I mean, I don't know what will happen. You know, honestly, I don't really speculate, but I'm thinking that's probably going to be you'll start seeing that more and more. You know, people are going to, companies, private or public, will start. My girls at Athens High School are I'm not sure how it's going to be. They're being told they have to mask up. You know, it's still kind of unclear as we proceed, but all my family's vaccinated, so I'm not really uncomfortable. But I don't know how it's going to work, you know, going forward.
Well,
I'm hoping I can go to the picnic tomorrow night, just because they've got a telescope that I can look through. That's hopefully, you know. But again, it's still a game time decision that I'm still uncomfortable, you know, just because I don't know what everybody else's opinions are at the club. I really haven't met anybody in person between both clubs, and I can.
There was a meeting at the Birmingham schools the other day where it got really out of hand.
Got heated.
One fellow stood up and gave a Nazi salute, and
No way.
Said Heil Hitler right in the
Are you
meeting.
kidding?
Everybody. Yep, it's the Birmingham school system the other day, and the people
Yeah.
got it.
I'm in Troy. I'm in
said,
Troy, Ken, and we had a similar
won't let-
meeting, but didn't get out of hand like that.
Well,
Listen,
that
you
got out of
guys,
hand.
before we go
crazy.
off on that, I think a lot of
Yeah,
us
we're
would like
done.
to go
Yeah, sorry.
look at
Sorry.
Jupiter
Sorry.
tonight. And I know Dale T
Yeah.
is one of them, and he's running the tech part of the meeting.
I
So
cool it.
I'm
I love
really
it.
sorry, but we need to shut it down for tonight.
No
Yeah,
problem.
yeah, good.
Good
We're
night,
all
you
with it.
guys.
You-
Good
Thanks,
night.
Dale.
Good night,
Pleasure.
everyone.
Great
Thank you.
meeting.
Good night.
Thanks, Dale.
Appreciate the talk.
Good night.
Take care.
Good night.
Bye bye, everybody.